Hello friends, welcome back to my class, that is Pandesar class. In today's class, we shall discuss about a problem on Lamis theorem and equation of equilibrium. Okay, and how we can club both those two equations to get a solution. So if at all you don't know what is Lamis theorem, please go back to my previous video and check it. What is Lamis theorem? There you will find 3 videos. First contain what is Lamis theorem. Second video contains a problem, basic problem on Lamis theorem, and third one contains a bit second model of Lamis theorem. In today's problem, you could see that there's a string which is tied at two ends. The ends are A and D. In between those two strings, there's a two weight of 20 Newton and 30 Newton being hung. Okay, so the question is, find the tension in the string T1, T2 and T3. Find the tension in the string T1, T2 and T3, and also find angle theta. So how to solve it? Let us begin. Now, this is the question what I have explained to you now. If at all you want to solve the whole problem at one stroke, it might be difficult. Okay, so first we'll break this problem into two halves and we'll try to solve it. Then it will become easy. So here first I'll break this part. I'm breaking this part. Okay, so here I'm breaking this part. Then we'll go for this part. Okay, so let us solve this part. So it contains see first we'll have a self weight W, that is 20 Newton. Given is not self weight, but the weight given is 20 Newton. Weight given is 20 kilonewton. Next we have tension T2. We have tension T2, which makes an angle 50. Which makes an angle 50. Next we have tension T1. We have tension T1. See here, angle between the vertical and this tension is 30. It means that if this is my vertical, this angle given is 30. Okay? These are given in the question. Now, if you could see here, you will find three forces, T1, T2 and 20 pure Newton forces. These three forces are in equilibrium condition. So, we can apply Lamis theorem on this problem. If I want to apply Lamis theorem, I should know this corresponding angle, I should know this corresponding angle, and I should know this corresponding angle. So, first we will find the corresponding angles. How to find it? See here, since I have extended this one, I am going to extend a line of horizontal. So there's a vertical axis and horizontal axis. This is pure 90, no doubt in that. No one should get any doubt. Since they both are horizontal and vertical, this is my 90. Next. Even from here to here, it's 90. But the given here is 50 degree. So this will be my, obviously will be 40. Any doubt? You should not get any doubt. Okay now? Because I am very slow. Now, even this should be 90. Now, if this small angle is 30, then obviously this angle should be 60. Any doubt? And this angle is obviously 90. I'll explain once more. If you could see here what I have done it. I have extended this line. So write again, or you will understand it. Just take a screenshot and try to understand. Okay? If at all you don't understand it, please comment me. I'll sure explain you again in the comment. Okay, or you can even text me mail personally. I'll just help you there also. So here all the angles and force are given. Now I'll be applying Lamis theorem at these sections. Okay, so I'll just redraw it again for better understanding. This is my 20 kilonewton. This is my T2. This is my T1. What is this angle? See, means from here to here. From here to here means what? This. See, follow this one. First, I'll write this angle. Means from here to here. It's 40. This small part is 40. Next, this part is 90. And again, this small part is 30. How much? Am I right? 160. So this is my 160. Okay? Next. I want this one. What I want? I want from this one is what? From here to here. I want this whole portion. Okay. See, from here to here it's 90. So 90 plus this small portion. That is how much? 60. So this is my 150. Any doubt? Next. I want this angle. Means I want this angle. I want this angle. That is only 50. Now we know the forces and we know the corresponding angles. We can simply apply Lamis theorem. So I will apply it. T1 by sine theta. Sine opposite to T1. So I want T1 by sine this one. Sine 50 is equals to T2. T2 by opposite sine angle. Sine 150. T2 by sine 150 is equals to 20 by sine this angle. Okay? Doubt? T2 by sine 160. Okay? Just check it out. Okay? This is what we have done now. I want T1 and T2. So first I'll write T1 by sine 50 is equals to, because this is known, no? 20 by sine 160. T2 by sine 150 is equals to 20 by sine 160. From this you can find T1 is equals to 20 into sine 50 by sine 160, and from this equation you can find T2 as 20 into sine 150 by sine 160. Open your calcium and please solve it. Meanwhile, I too will be solving. That is sine 50 by sine 160 into 20 into 20. You get it as T1 as 44.79. T2, how much? T2 you do it. T2 you will get it as 29 point. So this is all irrelevant. Okay? Don't forget its units. Units are very important. So we found T1 and T2. We found T1 and T2. Okay? Any doubt? So this part is clear. So I am just erasing this one. Here I write it as T1 is 44.79 and T2 is 29.23. Two values which we got. Now I'll just erase this part. Okay. So here we found T1 and T2. Now we also want T3 and this angle theta. Question is find tension. So we have found T1, we have found T2, now we should find T3. T3 comes in this portion. So I will break this portion into parts. So how? Weight is 30 kilonewton. This is T3. This is T2. Okay. Now, this angle is theta. So this angle is also theta. Any doubt? And just again extend it. This is, see, this is 90. Obviously, this will be 90. Obviously, okay. What will this one be? Check it out once. This one would be, if this is 50, this will be 40. See here, this is what? But see here, we could not find this angle theta. Our aim is to find this theta. Everything we are getting, okay, but we are not getting one angle theta. Unless we get this angle, we cannot apply Lamis theorem. Though here we have three forces, T2, T3 and weight, 30 newtons. But we do not know this angle, total angle. We just know theta. You try how much, but we will not get total angle. This angle we may get this angle, because if this is 50, this is 40, then this will remain 50. So we may get this angle. We may get this angle as 50, but this angle is unknown. Since the angle is unknown, here we cannot apply Lamis theorem. We should apply equation of equilibrium. Before that, we should know what is called equation of equilibrium. See, the horizontal force and vertical force and this other equation moment. These three are called equation of equilibrium. Okay now, all the horizontal force and all the vertical force, along with that a moment. Moment I'll be doing in the next class. So these all are called, only these three are called as equation of equilibrium. So I'll be applying only horizontal force and vertical force, because here I have only two forces. Okay. So how to apply equation of equilibrium? Okay. Now, since here we cannot apply Lamis theorem, let it be so simple. So here, first I'll write sigma x fx. All the forces in horizontal direction. Here T3 sin theta, it's here, okay? T3 sin theta plus T2. In this quadrant, my x is negative, so minus T2 sin 50 is equals to minus T2 sin 50. Since this is perfectly vertical downward, so there will be no effect on x-axis, is equals to 0. It means that T3 sin theta is equals to T2 sin 50. So T3 sin theta is equals to T2. What is T2 value here? We got 29.23. So 29.23 sin 50. So T3 sin theta is equal to how much? Tell me the answer. How much you got? So 22.3. So my T3 value is 23.39. Next, I will write in sigma f of y. So what? T3 cos theta, in this quadrant my y is positive, plus T2 cos 50, there is a weight vertically downward, means negative, minus 30 is equal to 0. Check it over it. Any doubt? Let me know. From this you can write T3 cos theta is equals to 30 minus T2 cos 50. So my T3 cos theta would be, solve it. Solve it, let me know. My T3 cos theta is 11.21. 11.21. Okay. So shall I come? So from this, let this be my first equation. Let this be my second equation. On solving 1 and 2, you have T3 sin theta by T3 cos theta is equals to 22.39 by 11.21. So you have what you have? That implies tan theta is equals to how much? Let me know. Tan theta is equals to how much? 11, or else simply shall be continued directly. From this you can see that because sin by cos is equals to tan. Sin by cos is tan. So theta is equals to tan inverse 22.39 by 11.21. How much answer? Check me the answer. How much? So tan inverse 22.39 by 11.21. How much? How much you got? 63.40. So my theta is 63.40. So my theta is how much? 63.40. My theta is 63.40. Now, this theta, either you apply equation 1 or 2. So if I apply equation 3, you see here T3 cos theta is equals to 11.21. So here we get that T3 is equals to 11.21 by cos theta. What is theta? 63.40. So tell me the answer, how much you got? .03 or kilonewton. So my T3 is 25.03 kilonewton and my angle theta is 63.40. These are my answers. See, though my video might be a lengthy video, but I am going in detail so that you do not get doubt at any point. And please don't forget to subscribe my channel, and you can ask your friends and relatives to help me. You are just helping me in this way, okay na? Please help me out. Take a screenshot and stay tuned for my next video. Thank you.